Large language models are incredibly powerful, but they don't automatically know exactly what you want. Prompt engineering is essentially the steering wheel for the LLM. Today, we're going to learn how small adjustments to your instructions can completely shift the direction of the output. Many people think prompting is just asking a question, but in industrial strength apps, it's a delicate art and science. You aren't changing the brain or weights of the model. You are simply providing the right environment for it to succeed. This is the fastest, lowest effort way to get better results. Language models are pattern matches, so ambiguity is your enemy. If you give a prompt that has multiple interpretations, you'll likely get an unintended response. You need to define the task, the format, and the limitations with laser precision. Your choice of verbs is a key tool for steering the model. Instead of saying, think about summarizing this, use direct instructions like, summarize the following text. Precise verbs activate the specific training data the model needs for that exact operation. Positive instructions are generally more effective than negative constraints. If you focus too much on what the AI shouldn't do, it might lose sight of the actual objective. Tell the model directly what you want, as this aligns better with how it processes information. While you need to be specific, you shouldn't be wordy. Unnecessary fluff can confuse the model or obscure your primary instruction. Remember, what is confusing to a human is likely confusing to the model. Zero-shot prompting is the most basic level where you give an instruction without any examples. It relies entirely on the model's pre-training to understand the task. This is perfect for common tasks like translating a simple sentence or summarizing a short story. One-shot prompting provides a single demonstration of the input and output before you ask the model to do the work. This serves as a template for the model to follow. It's very useful when you want the AI to stick to a specific style or structure. Few-shot prompting uses 3 to 5 examples to show the model a clear pattern. This is incredibly effective for tasks like data extraction or complex classification where you need nuanced consistency. Providing a few high-quality, diverse examples helps the model generalize much better. Modern models with massive context windows can now handle many-shot learning. You can actually include hundreds of examples directly in the prompt. This allows the model to learn incredibly intricate patterns on the fly. A system prompt defines the overall context and permanent behavior for the entire session. Unlike a regular question, it establishes the model's personality and the safety guidelines it must follow. Think of it as the operating manual for your AI assistant. Role prompting tells the model to act as a specific character or expert. If you ask it to act as a senior contract lawyer, it will respond with much higher legal precision than a generic assistant. Assigning a role provides a logical framework for the tone and expertise you expect. To avoid confusing the AI, use delimiters like XML tags or backticks to separate your instructions from your data. This ensures the model understands exactly which part is the command and which part is the information it needs to process. It's a simple trick that prevents a lot of common errors. When you need data for other programs to use, don't ask for text. Ask for structured output like JSON. Requesting a specific format forces the model to create a structure, which actually limits its chance to hallucinate or make things up. It turns raw text into validated, usable data. You can use tools like Pydantic to transform AI-generated JSON into validated Python objects. This creates a safe zone for your data, ensuring it conforms to the exact types and rules you've defined. This is a core requirement for building robust, automated workflows. Chain of thought is a powerful technique where you instruct the model to think step by step. This mirrors how humans solve hard problems by breaking them into smaller parts. Even just adding the phrase, let's think step by step, can significantly boost accuracy on math or logic tasks. A major benefit of QoT is that it makes the model's reasoning transparent. You can actually see the logical steps it followed. This makes it much easier to understand why an answer was given and to debug the process if it makes a mistake. Self-consistency involves running the same prompt multiple times and picking the most common answer. It leverages the model's probabilistic nature to find the most reliable path. By taking a majority vote, you can drastically improve results on complex tasks. Step-back prompting asks the model to identify a general principle before solving a specific detail. For example, before writing a mystery, you ask, "What makes a good detective story?" This activates the model's background knowledge, leading to more insightful and accurate final answers. Tree of Thoughts allows the model to explore multiple reasoning paths at once. Each thought is a branch, and the model can self-evaluate which one looks the most promising. This is perfect for the hardest problems that require exploration and backtracking. Think of a simple prompt like a static paper map. It shows the world as it was when printed. Agentic prompting is like a live GPS. It knows the goal, observes the traffic of new data, and constantly recalculates the path to get you there. Beyond just prompting, we have context engineering, the systematic discipline of designing the full informational environment. This theory argues that the quality of the AI's output depends less on the model's architecture and more on the richness of the context you provide. Context engineering includes everything: the system instructions, documents retrieved from a database, and the results from tool calls. It reframes the task from answering a question to building a complete operational picture for the agent. React is a paradigm that combines thinking with real-world action. The agent generates a thought, takes an action with a tool, and then makes an observation based on the result. This iterative loop lets the agent adapt to feedback in real time. Tool use allows the model to generate a structured request to call an external function. The model doesn't do the math or search the web itself. It asks an external system to do it. This breaks the limitations of the model's training data. You can actually use models like Gemini to improve your own prompts. By asking an LLM to analyze your prompt for ambiguity or lack of specificity, you can accelerate your iteration process. It turns the AI into a collaborative partner in the engineering process. Frameworks like DSPY treat prompts as programmatic modules that can be automatically optimized. Instead of guessing, an optimizer tests different combinations of examples to see which one gets the highest score against the dataset. To wrap up, prompt engineering is about steering with precision. Use chain of thought to reveal the reasoning, and use structured outputs to make your AI reliable. The quality of your results depends on the richness of the environment you build. We are moving from AI that just chats to autonomous partners that plan and act. By mastering these design patterns, you are learning to instruct machines not just on what to do, but how to be. The canvas is in your hands, and these patterns are your brushstrokes. It's time to stop just using AI and start engineering the future. Thank you for watching.